Hello, friends, and welcome to yet another exploration with the divided bead frame. So divided, and if you don't have one of these, it's very easy to make. There's a template to print out, glue to some cardboard. You'll need some things to cut and punch with to make these holes in these big frames, and then some wire or strings or pipe cleaners and some beads or something, so you have something to count with. Then you'll have a divided bead frame. You could do addition, subtraction, multiplication on this, but it's really meant for division because you have this side for your dividend and this side for your quotient. It's pretty fantastic. And the divisor goes down here. Well, friends, you've been working with what has been used, recording how much you use each time you divide, and subtracting that to find your intermediate remainder. You did that with short division. Those have divisors with just one digit. What if you want to have a long division problem and do what has been used? Well, you can do that. You just need a bead frame, a piece of graph paper, a pencil, and a strip of paper for your divisor. Now, your divisor, we're going to use 2 digits today, but you could have up to 5 digits. It's pretty fantastic. Oh, you'll also need a problem. Let's think about a really interesting one like 12,597 divided by 34. That sounds pretty good. There's my problem, tableau included. Okay. Now we need to create this dividend on the bead frame. So there's 7 units, 9 tens, 5 hundreds, 2 thousands, and 1 10,000. There we go, 12,597. Fantastic. And we need to get that strip of paper so we can line up the digits of our divisor perfectly. It really does make a difference. There's our 4 units, and there's our 3 tens, and hey, some paper to spare for later. Because once you do one of these, you may not be able to stop. It's a common side effect of doing awesome division. So where are we going to put this? Of course, in the 2 largest categories where it will fit, starting at those largest on the left categories and those smaller ones that we can't really fit a lot into yet. All right, we're going to be taking away groups of 34 right out of there and recording them over here. But we actually can't start here. There's not enough for us to divide out. We're going to have to move down to the hundreds and start dividing there. Let's begin. Taking away a group of, well, only 2 so far, exchanging so we can take away that last bit of 3. And there's a bit of 4. We'll record that on our hundreds wire. There's 3, taking away 1, exchanging 2, 3, 4 for another one. There's another group of 3 and another group of 4. And we can stop right there. We were able to get 3 groups of 34 out, and well, we only have 23 left. But how do we make that intermediate remainder appear? We got to think about what 3 groups of 34 is. It's the amount we just took out of that. And something you might even try to do before you start one of these problems is to figure out all the multiples of your divisor 1 through 9. And I mean, 1's pretty easy, but 9 might be tough. But those are going to come in very handy because the largest, farthest you can go is 9. Let's write down our answer above the hundreds. Now, if you notice, we were working with these 3 digits here. It looks like 125. How much did we take out of that? 102. So from 125, we're going to subtract 102. Do you think you can solve that real quick? Yeah. Yes, it does so happen to be right there, just in case you need to check. You've got some control of error here. The intermediate remainder is right there, and now it's also on our paper. We're going to drop that next digit, that 9, down, and we're going to be working with all 3 of those digits. Take a look. Our 4 and our 34 is going to drop down as we slide over right underneath that 9. So that 239, that is the monster we must slay now by taking away bits of 34 from it. Okay, let's begin. Taking away 3 and taking away 4 and recording it over here. Exchanging over there, taking away 3, taking away 4 and recording over here. It's pretty easy. There goes 3, there goes 1, exchanging so we can get rid of 2, 3, and 4, and marking that down. There's another group of 3 and 4, marking it down. Ooh, looks like we can't go any further, right? Of course, you see that one over there. Let's exchange that, and we can continue. There's 3, 1, 2, 3, exchange, 4. Another group, 3, 4. Another group, 3, 4. Another group, whew, and we're done. And you can see that intermediate remainder, it's 1. That might even give you a clue about what we just created. So, do you know what 34 times 7 is? 238. And just in case you weren't completely sure if it was difficult or something, well, there's only 1 left. I mean, how do you get that? 238 subtracted from 239 is equal to 1. Oh, and writing down our answer. So far, 370 something. What's it going to be? Well, let's drop down the next digit to find out. And actually, as we slide over, you might have already figured it out. We're at our final remainder already. We can't take any more away. And what is really cool about this number is it's half of the divisor, that little bit that's left. But what were we able to take out this time? Absolutely nothing. And so we do also want to record that we used nothing. Just keeps everything in the right place. And what is that answer? 17. You can circle that if you like, because that is the final remainder. 12,597 divided by 34 is 370 with a remainder of 17, conquered on this divided bead frame. Well, I can't wait to see the fantastic explorations you make with this experimental material, and let me know how it goes. Goodbye, friends.